today we wanted to talk about pathways to a sustainable AI portfolio. Just as you were introducing me, Clemens, there, I've been in the AI industry since 1985, where AI was not a big thing, nor was ESG. And I didn't think 35, 36 years back, I would have thought that I'll be giving a talk around sustainability of AI. And I wouldn't have imagined
see you in the Q&A.
Yeah. I wouldn't have imagined that AI would have been so big to talk about sustainability and AI together. Nevertheless, here we are. So what we wanted to do today, Joe and myself, walk you through some of the key trends in AI, especially in deep learning. Look at both AI for sustainability very briefly. I know that's the focus of this, but we're also very, very concerned about the other side of it, to what extent AI is causing more of the carbon footprint and how we could reduce that. So more sustainability of AI or sustainable AI. So that's where we want to focus our efforts on today. And then look at what are some of the AI sustainability goals that we should have, and what are the ways in which companies can start bringing in some of that carbon consciousness and carbon decision making into their data science or AI. So that's what we wanted to cover. So if you go to the next slide, we have all seen headlines like this. So the first one is around GPT-3, and some of these models, which are huge models. When I say huge, they are 175 billion parameters is what this GPT-3 is, and again, that's considered even smaller now, with Google Brain coming up with a 1.6 trillion parameters. So these models are huge. And some of the challenges with these models, there are three main challenges, as you see in this side of the article. And the one is, even though these models are huge, they are not necessarily understanding natural language. So the idea behind GPT-3 is you give a sentence and it really comes up with a very good passage as if written by a well-known, knowledgeable person, might be an undergrad or a high school student writing an essay on a certain topic. So very powerful, but doesn't mean that it really understands the logic behind it. And in addition to that, the one other big issue with this is the consumption of electricity. In other words, the compute time it takes is sometimes quite large for training and for inferencing, as a result of which it is having a significant carbon footprint. Again, there have been some controversies around that, but nevertheless, if you look at the next news around MIT News, basically people saying that no, the numbers that were originally estimated at some false assumptions, so the numbers are much lower, and the carbon footprint of machine learning would essentially plateau, right? So again, even though it'll plateau, it is still a huge and significant drain on energy consumption. So if you go to the next slide, this is something that Google and UC Berkeley just published. One of the things that they are urging is what kinds of measures you can take to bring down the carbon footprint, bring down the energy consumption, bring down the carbon footprint. So 4 M's, as they talk about, can we come up with a different architecture, and based on that architecture, you can get 5 to 10% savings in energy. Can you look at different types of processors, so specialized processors for deep learning, especially these large networks of billions and trillions of parameters? The third, if you're centralizing all of these things in the cloud, and then you're placing the cloud in the right areas where the energy is sort of more sustainable energy, then you could save even more. So that's the mechanization through cloud, and then moving the compute to a lower energy or lower carbon footprint area. So those are some of the things. What we want to do is sort of really expand on that and bring the consciousness around sustainability to the data scientists. So if we go to the next slide, so we've just gone through this. So there's a huge number of data. So some of these models, they are being called foundational models. This is just the start. And there are a number of others, extensions of GPT-3, GPT-4, GPT-J, and a number of others where the compute is huge. The data is huge. Larger the data, the more complex are the models. As I said, 175 billion parameters, now going to 1.6 trillion parameters. That's going to increase, which really means the compute power to train some of these models are also going to increase, resulting in a higher energy consumption and higher carbon footprint. So what we are really after here is going and to the next step. We are seeing that the AI models run the risk of being unsustainable. So if you go to the next slide here, on the one hand, we have seen AI essentially make a big impact in a number of sustainable areas. So again, we are picking off here from the UN Sustainable Development Goals. As we all know, there are 17 Sustainable Development Goals. And AI, and there are a number of use cases, and we have written quite a bit on this topic on what are some of the use cases that can benefit planet Earth. If you look at climate change, so there are a number of AI use cases, biodiversity and conservation, how can AI help? Healthy oceans, water security, clean air, weather and disaster. In all of these areas, we have AI essentially helping us reach these targets better. In fact, I think one of the items here is 79% of our targets can actually be met by powering them with AI. So AI definitely has a useful role to play in sustainability. If you go to the next slide, but unfortunately, it also impacts the environment in very specific ways. So here again, we are looking at what is the impact of AI on sustainability. So first and foremost, it is the clean energy. Energy to fuel AI efforts tends to be unsustainable, as we just went through that example of trillion parameter models and the energy consumption of those and the carbon footprint. Then the other interesting area about AI is as these models get bigger and bigger, requiring a lot of data, it is essentially concentrating on a few small companies, essentially creating more of a disparity. And I know at the UN SDG conferences, AI for Good conferences, we talk about the inequity that is happening through AI as AI gets used, and deep learning and the things that we just talked about is expanding that inequity, not only between countries, but between public institutions, academic institutions, and companies. So again, a few companies are the only ones who can really develop these kinds of large models. Consumption and production, again, back to the carbon footprint. Similarly, the climate action. So there are a number of areas where AI is impacting the already agreed to carbon footprint and makes it even more difficult for us to reach if you are going to be using AI, and then AI is actually going to be causing more emissions rather than reducing emissions. So it's not that not only do we want to reduce that 79%, but we don't want to increase any of that carbon footprint. And that's what some of these models will be doing. So what we wanted to address here, we need to move beyond this type of AI where we are, I would say, being a data scientist, maybe indiscriminately using models just because they are there. And one of the key aspects to these deep learning models, they are much more accessible to people. And obviously it comes at a cost, but the cost is the compute cost is what the vendors are factoring in, not the planet cost. So we really need to move from this domain of, hey, it's available cheaply, therefore I can use it. It's easy to use GPT-3, therefore I will use it, to a very different model. So if we go to the next slide, the concern of data scientists have been, if you like, largely along these three areas. So first and foremost, we want to solve the problem. The more complex the problem, the more we think AI can solve it, right? So using deep learning or other forms of AI, we want to approach complex problems, which is fine, which is where AI has a role to play. And when we do that, the primary concern of data scientists and AI scientists is, can I make this work? How accurate can the model be? So the focus is very much around accuracy. And the third parameter, obviously, we look at is what is the return on investment? So if we put in certain number of dollars, are we getting the return with our AI investment? So those are the three primary things that most people think about when we look at AI. So what's the problem? Can we address it? We cannot address it using any other mechanism. We have to use AI. And then what is the accuracy? And when would we get the return for it? Go to the next slide. I think we really need to bring in this last element here, which we and others have talked about as responsible AI. So not only addressing the three parameters, but looking at issues around bias, fairness, explainability, and a number of those things. And one of those considerations we believe should be, is it ethical to build an unsustainable AI? In other words, factoring into responsible AI, this notion that are we building these AI models in a sustainable way? Not that, of course, we need it to be accurate. Of course, we need it to be fair, justifiable, and so on. But we also want it to be sustainable. How do we get there? What do we do to create sustainable AI? What practices do we need to change within our data science group so that we can aim towards sustainable AI and use the AI for reducing the carbon footprint and, as much as possible, reduce the footprint that AI itself causes? So with that, I'm going to hand over to my colleague Joe, who will walk us through what are some of those steps that we need to take. Joe?
Yeah, hi everybody, and good morning, and hopefully everybody can hear me. So I'll take off and cover some of the practices that can be introduced to create a more sustainable model development environment. But I think it's first worth kind of talking about how sustainability fits into the kind of the broader framework of responsible AI. So very quickly, when we talk about responsible AI, we're talking about two primary principles, one being interpretability and transparency. So can I explain how overall my model is making decisions within a certain topic area or domain? Can I explain the individual decisions that my model is making to an end user that's consuming those decisions? And is the system reliable? Is it robust? And more importantly, is it ethical? And on the screen, you'll see the general guidelines or principles for ethical AI, including accountability. So is there a single person responsible or a single entity responsible for the actions that the model has taken in cases where it may encounter a moral or an ethical dilemma? Data privacy. So are we using as little personal information as possible to develop or design an AI model? And are we doing so in a way that's protecting that individual's privacy? Safety, focusing on making sure that the AI system isn't somehow compromising the safety of the environment or an individual. Compliance with laws and regulations in the domains in which the AI is operating. The amount of intervention and control that a human has on the system in regards to kind of an AI application, fairness and kind of all the shapes that fairness can take, and ensuring that models are consistent, they're not discriminating in any certain way that creates a much larger kind of societal or organizational issue through the use of the AI. And then finally, beneficial AI. And this is kind of where we'll spend most of our conversation today, specifically around sustainability as it fits into beneficial AI. So is AI being used in a way that promotes a common good? And when we talk about sustainability, we're really focused on thinking about how we can systematically reduce the overall footprint and emissions of a model and a model portfolio throughout its life cycle. So that's not just training. So there's a lot of focus on these large AI models like GPT-3, where a vast majority of the footprint at least the footprint that's kind of been under the microscope has been in the training of the models because of the amount of compute and time that goes into that. But it's important to think about the overall lifetime of a model, because far more of the compute cycles and energy consumption of a model is going to occur through the process of making decisions and even maintaining that model and the consistent and ongoing retraining of the models. So I will cover a few areas today where we think there are opportunities to introduce practices and principles that help with instilling sustainability as a concept within the data science life cycle. I'll focus on three of these in a little bit more detail later, but just kind of quickly going around the circle that we have here. Data is kind of the common starting point for a lot of activities related to your model development, and it's not different for sustainability. So every data point that you collect has to be searched, it has to be integrated, it has to be transformed, and it has to be incorporated or could be incorporated into your model. So it's important to think about, are you collecting data in a way that it's going to be useful, and are you collecting extraneous data that could ultimately lead to greater consumption of energy down the road? When designing a model, there should be a focus on reducing the complexity of the model overall, but also around reuse and recycling of models where appropriate. Sustainability really isn't, at least right now, a critical factor when determining the efficacy of a model, but that is something that we think should change and should be considered as kind of a critical metric when evaluating a model for function within an organization. So moving beyond just kind of a myopic view of performance and of adding sustainability or emissions as part of the calculus when determining whether or not a model is suitable or fit for purpose. Deployment operationalization, this is a common step, and like I said, this is where you're going to see the most consumption of energy with your models over the lifespan of the model. And what can we do there that can help us reduce that energy consumption and make the models more efficient after we've conducted the training. Our ability to act and our ability to make corrections, it's only as good as our ability to kind of see and peer into the portfolio. So thinking about how we better monitor models with a lens towards how much energy is being consumed is also kind of a critical step when we're thinking about the holistic incorporation of sustainability. The ecosystem, and Anand had hinted on this, and kind of the four M's, specifically the mechanization, but dealing specifically with the infrastructure. This is an area where there's still quite a bit of control, and a lot of organizations rely on cloud environments, which give them access to improvements in hardware and probably shorter cycle times, which may mean better energy efficiency, but also gives you control over where your models reside. So you can kind of pick and choose where your compute cycles are running in the cloud, and those areas being areas where there may be a greener footprint in terms of energy consumption. We can reduce the energy that our models consume as much as possible, but if the energy that they are consuming is still extremely CO2 emissions heavy, it really does us no good. And then finally, governance, kind of incorporating sustainability throughout the life cycle. And that's no different from some of the other responsible and ethical AI principles that we introduce. There are metrics that we propose being introduced for things like fairness and bias. Sustainability is one of those additional metrics that we think should be incorporated in the decision process as you move your models through the development lifecycle. So I'll go into detail before we close out here into three areas: design and development, evaluation and selection, deployment operationalization, primarily because I think these are three areas that are generally easier to kind of adopt some of these principles, where there's not a lot of infrastructure, there's not a lot of capability development needed to kind of instill these principles starting today. These are things that you could do tomorrow, or at least instill tomorrow as part of your development process, and start to see some rewards. So first, we'll start with design and development. I think in general, there's there's sometimes a trend with data scientists to use more complex models because they are enticing. So a GPT-3 on paper does seem very enticing as a language model because it appears to be extremely robust and a good baseline model for a number of language modeling tasks. The same for BERT. I would say in general, we try to focus on using simpler models where possible. So if a decision tree can do the task just as well as a deep net, that's kind of the first thing that we'll go with for a number of reasons, from a cost and maintenance perspective primarily. But from a sustainability perspective, there's fewer compute cycles involved with some of those models, especially for training and overall inference. But in cases where that's not possible, and we have had cases where the benefit is kind of far outweighed the cost of using a large net. So we've developed some models in the regulatory compliance space that read policies using language models. And those models started with much simpler models to begin with, but over time we've moved to BERT as a primary language model. So it's another kind of a smaller version of a GPT. More importantly, like we've also trained our own version of this. So we've taken the added cost of training a model to be somewhat domain specific, operating in the financial regulation space. We saw, and the reason that we went down this pathway is we saw nearly a 10% increase in the model's performance. So when looking at the accuracy, the return on investment, it made sense to move forward. But in order for us to simplify overall the ecosystem of models that we've built out, because it's not just one model, we're taking that one model and we're using that as a basis for all other model development going forward. So any decision that we're making in the RegTech space using an AI model will all form from this one foundational model and avoiding us having to train and tune or fine tune these large nets for multiple tasks. The second is that we'll focus on is the introduction of emissions as a metric as part of your model evaluation. So I mentioned simplification. You might see small trade-offs in performance when moving from a decision tree model to a deep net. But those trade-offs, I think, when placed in the light of the energy consumption, the cost of developing and maintaining the model, may lend itself more towards utilizing that simpler model as part of the solution. But it's hard to say that if you're only kind of myopically focused on the model's accuracy. So it's model selection is always kind of a balancing act of selecting a model that is fair, that is removed as much bias as possible, that is safe, that is accurate. And now we're suggesting to introduce additional complexity there and throwing in emissions as a critical metric. I've had situations over time where we've built models, and ironically enough, we've worked on developing a commodity trading model that focused on wind energy. And looking back on that, I don't think that we provided a very critical lens as it relates to how that model was maintained, specifically the energy consumption around it, because the model itself took a day to train. We were integrating all historic data into the model, increasing the training time. And I think had we looked at it as should we really be training this model to squeeze out a few dollars and cents as a trading system? Could we actually save? Could we reduce energy consumption if we were to kind of rethink or reevaluate that training regimen that we were proposing to put the model through? And the final that I'll leave you with is around principles that can be helped with deployment operationalizing models. So when we talk about operationalizing models, that usually just means taking your experiments, wrapping them as hardened software that can scale, and deploying them in your infrastructure. This last step is more of a software development activity, but I'm proposing that really compression needs to be a last step, or a reduction in the model's footprint needs to be a last step. And there are techniques that are well established for doing this that have been very common in the edge compute space. We use them today as we build models for VR and AR headsets, because you have a very compact compute environment that you're deploying models on. But this is rarely used in the enterprise unless you're like a very mature organization that's extremely conscious about model throughput. But compression of a model can reduce larger model sizes by up to 40 to 50%, just in terms of the size, and can also reduce compute times by up to 70% in certain situations. The BERT model that I mentioned earlier is one that we were using as a foundational model. With quantization, which is a technique for compression, we see a 50% reduction alone just in that model, in terms of the inference time and the compute cycles used for inference. And this isn't the only technique. There are other techniques that are starting to emerge and become more common, including the use of artificial intelligence as a means of identifying more robust, more secure, more sustainable artificial intelligence architectures, neural network architectures. So we're using AI to design AI where sustainability could be introduced as a function in the objective for that AI. So I'll wrap with some key takeaways, and I'll leave you with some next steps that can be taken to kind of start to instill this discipline as part of your model development. But first, I mean, AI, it's the potential is there for it to be a critical factor in creating a sustainable society. But more importantly, we can't ignore the fact that we need to maintain AI sustainability as well. Responsible AI is the framework in which sustainability originates when we talk about AI. So that's the lens in which we need to view AI development, and it works in our favor that sustainability is kind of part of that. Sustainability is within AI, it needs to be holistic. So it needs to touch governance, model monitoring, your infrastructure, your development, your deployment, and your evaluation of models. And finally, we can take quick steps in introducing these principles into your organizations to begin thinking about your model development sustainably. But that requires us to think about new capabilities that can improve model efficiency, architecting in ways that maximize the reuse of models and maximizes simplicity, and also kind of reformulating the way that we think about value that's generated by the models. So finally, 3 steps to getting started on the journey to sustainable model portfolio. So the first is to get insight into your AI portfolio. There are tools out there that allow you to kind of footprint all of your models and kind of understand how much energy your models are going to consume. And more importantly, those tools can be used as part of the development lifecycle to not only view the model's energy consumption at training time, but also over the life cycle of the model. Taking advantage of instrumentation throughout the life cycle is also important. So we can't change or can't manage that which we're not measuring, and instrumenting your model so that you can see and understand its energy footprint is critical. And finally, a simple change in how your teams operate and how your teams think about model development, instilling a simple to complex mindset where we move up the complexity curve only as necessary and as the problem warrants. So with that, I'll open it up to question and answer, and also, Anand, if there are any other final comments.
Yeah, no, I think you covered everything. Thanks, Joe. So open to any questions.
Great. So yes, thank you very much for the presentation. It's also from the timing, it's sort of incredible because just yesterday, NVIDIA has shown the new Hopper architecture, which is actually directly aiming of increasing the energy efficiency of transformer networks for transformer models, for example. So what are the odds? This happens just a couple of hours before. This actually brings me to my first question. Do you see this as a future trend, where, let's say, similar to cars in the past, there will now lots of innovation in the semiconductor space will happen to lower the cost, or let's say lower the power consumption of training models?
Yes, I would say definitely yes, Clement. So it's not just we are talking about it. I think there's an increased awareness. Obviously, there are a number of AI scientists, AI researchers working in the sustainability, and it's almost sort of hypocritical for us to use AI in sustainability, and in that process, as Joe was explaining, basically contribute more to the carbon footprint, right? So it doesn't make sense. You might as well not use AI if there is going to be a net increase in carbon footprint. Just because we like AI doesn't mean that we should be increasing. So in that sense, I think there is a increased awareness and consciousness of the dangers of using AI in an unencumbered fashion. So I think we will see more, not only companies like us and others adopting, again, we just saw the paper from Google and others adopting it, but I think it'll also become part of what the governments and the regulators and other bodies would want. And in fact, there's a call for many of these large deep learning models to not only talk about accuracy and compare the accuracy, but also declare what's the energy consumption here, what is the carbon footprint, or at least the energy consumption, what is it, and what is the compute time. So basically to lay it out so that people can then do that comparison, not just in terms of accuracy, but also in terms of the carbon footprint. Yeah, definitely, I would say that is a big trend.
Okay, thanks a lot. Because now we also received some questions on Slido. Let's start with the easiest one first. Will the slides be available for download later? This is actually a question to you.
Yes, we can definitely make it available. So we can send it to you, Clemens, and then you can make them available.
Okay, excellent. And also, all the keynotes will be available later on our YouTube channel, which we have probably shown you 50 times already, but you will see it another 50 times, so don't worry. Then the next question is, where is the market for AI in the energy sector? Which would you consider the segment with the largest prospects? So I assume this is in a sort of, is it in transmission? Is it in virtual power plants? Is it in consumption, or wherever?
Yeah, no, very good question. So we definitely are seeing quite a lot of AI use cases in the energy and the power sector. I would say it happens in almost every area, right? So I'll just take a couple of examples. In the transmission side, we have definitely had a number of AI use cases where we are monitoring the transmission lines, using drones, using images, so that you can essentially restore power, especially after a disaster, much more quickly. We are seeing there. And we are also seeing things in the not in the upstream, but more in the downstream, where people are looking at trading energy, so looking at the futures, forwards. That's the example that Joe was giving. So maybe, Joe, you can elaborate more on the trading side. But there are definitely across the board, what I would say, there are AI use cases. And energy happens to be, I think, the second largest or maybe the third largest user of AI as well. After the media and telecommunications, they're actually ahead of this was a surprising result for us. So manufacturing and some of the energy and utility were heavier users of AI than some of the other sectors like healthcare and financial services.
Yeah, well, one more that I'll add, I think we see a lot of AI on the edge as it relates to predictive maintenance of equipment and instrumenting equipment and kind of deploying models to monitor those equipment. So I think we see that quite a bit of manufacturing and the airline space, anywhere where there's a lot of expensive equipment, but energy is a pretty common industry where that's present as well.
Okay, thanks for that. Maybe if we look more at Slido questions, what are the main applications which you have seen in the renewable energy sector? Which one of these do you see as the most efficient and impactful for producers or investors? Could you give us a flavor on that?
Yeah, interesting question. I know there are a number of different renewables that we are seeing. I would say a lot that's being done on the solar side, as well as wind and wave energy as alternatives. So we have some experience in doing some of the modeling, especially for the wind generation. as some of these gets very complex, the way I think AI is being used, both for solar as well as wind. In the case of solar, just being able to move the solar arrays even to a small extent, very minute extent, so that you capture the maximum position wherever the sun is moving, right? So that's one of the big use cases within AI for solar. Same thing with wind, being able to change the orientation of the blade so that you capture the maximum wind. So efficiency and AI focused on changing the control so that you get the maximum efficiency is where we have seen the AI being used. But I would say those are some of the areas of renewable energy.
Okay, thank you very much. And yeah, with regard to the time, because our next keynote speaker is also already here, one final question. It says, do you have experience with AI in power congestion management?
In power congestion management, I would say the way we have dealt with the power congestion is essentially matching the demand and the supply. Again, as I mean, the energy sector, obviously, everyone here would know this, that as the demand increases, the supply and the cost of the supply increases. So your base load is typically the renewable energy, so hydroelectric, maybe gas and other cheaper forms. As you get to the higher end of the demand, you then have to start producing much more of the nuclear energy and the higher cost energy. So how do you essentially look at the demand, and can you reduce the demand? Again, most of the energy trading that happens in the exchanges is a one-day forward. So you bid for tomorrow. So by being able to look at the pricing, you can change the demand structure and try and match the demand and the supply, again, based on weather conditions, based on the demand and need. So the pricing is the one that changes the congestion. Of course, things happen when there is an unscheduled droppage of certain power plants or energy. So that's when the prices speak. And that kind of a management of matching the demand and supply through pricing is what we have seen most.
Excellent. Yeah, so thanks a lot for your keynote, and also thanks a lot for sticking around for the questions, which were surprisingly large in number. This actually means that you showed something very relevant for the audience. I assume you will not stick around on the B2Match platform, because for you it's now almost 4 a.m. in the morning. So really thanks a lot for joining at this ungodly hour. And yeah, we will make the keynotes available later, and we will also send you the link for dissemination in your network. So thanks a lot for joining.
Thank you very much for having us here.
Bye.